Hello and welcome back. Today we're going to do a quick tutorial on 3.5, the map program in Scratch. To do this, we're going to need to use Google Maps to get a map. And of course, we're going to create the project in Scratch. Before we jump in, let's look a little bit at the instructions. We need to log into Scratch. We need to open Google Maps or some other mapping program and locate two different points of interest on it. Could be your house and the school or another location. Make sure that the locations are close enough that you can see the streets between the points of the map on a single screen. We use the snipping tool to create and save a screenshot of your map. And we're going to upload that map as a new background. And then we're going to use what you've learned about moving to get a sprite to travel between the 2 points of interest when the green flag is clicked. The catch is the sprites must travel along designated roads. So, in the rubric, we've covered most of that just in the description, but the background needs to be a map showing your starting and ending destinations. The sprite needs to start at the first destination when the green flag is clicked. It needs to move along the streets. It needs to point in the correct direction, depending on which way it's moving. And it needs to indicate when it has arrived at its destination. That's usually done with the say command. This project has an enhancement. You need to add a feature of your own choosing that involves movement and or animation. And there are some suggestions there. I leave that to you to figure out how to do them. That's how extensions work. So let's start by going to Scratch and opening up a new project. So here's my Scratch. I verified that I'm logged in, and then I hit Create to make a new project here. And in this project, it'll take a moment. I actually will use the cat, but the cat size is a little bit too big, so I will shrink the cat maybe to 40%. Yeah, that'll work. Okay. You could change the costume size, but then you'd have to change both costumes exactly, and that's very difficult. So it's much easier to use the size control here or the size controls under looks. Many of you have stumbled across those. Set size to 40% would be a good command. I'm just going to stick this out here for us to have handy when we get ready on the coding. But now, let's see, we also need to name our project. This is 3.5 Scratch Move. Let's call it the map program. All right. Second thing we needed to do was to go to Google Maps and find somewhere near our house. How convenient. It's come up right over my house. Olympus High School is right here. Whoops. Olympus High School is right there. And where could we go from? Let's go from Evergreen Junior High. That's not too far away. It shows on this map. In order to capture this map, I'm going to scroll it just a little to the right so that I don't get this stuff in the way. And then I'm going to come down to the Windows bar and hit Screen Capture. I forgot I'm not on a Windows machine. I'm going to have to use the Mac version of that. It lets me drag a rectangle. You want to size that rectangle to be about the size of the Scratch screen, and you want to be able to see your destination and your starting point on the same thing. So the screen's about 3 high by 4 wide, something like that. We'll go ahead and take a screenshot of this and save it to a file. And that's done that magically on my Mac. Yours will be slightly different when you're working on a PC. Go back to Scratch. we're going to go to the stage. We haven't been here before unless you've played with backdrops. But the stage is where we set what's behind everything. I'm going to go to backdrops. It comes with a blank backdrop, not very interesting. I'm going to use this command down at the bottom. Scroll up to upload backdrop and then click. And that lets me look around. My thing saved on the desktop. There it is. It's got a very ugly name. We're going to open it anyway. And in comes a backdrop that looks like our map. It's almost the size of the screen, not quite. So if we look on our screen, we see a little border on the two sides. We're going to fix that. First, I'm going to name it differently. I'll just call that the map. Just name that costume differently. And then we need to convert it to vector. Right now it's a bunch of pixels. If we draw on them, we'll destroy them. If we stretch them, it's ugly. So if we convert it to vector and then use that arrow key to select the whole thing, we can very easily stretch it to fill our whole screen. And so that's a much cleaner look over there. We have our map. The roads are still legible. And we're done with our backdrop for now. We could take that one and delete it just so it doesn't come back to bother us. And jump back over to the cat. Now comes the motion part. The cat needs to start at Evergreen Junior High, so I am going to actually move the cat to Evergreen Junior High. Notice that my X and Y locations have updated. X is -50, Y is +140. I don't need to remember that. I can just say go to that. When do I want to do that? I want to do that when the green flag is clicked. So when the green flag is clicked, it goes to that spot. If I were down here, hit the green flag, it goes right back to that spot. Very good things to put in the beginning of your program. Now let's look for where are the roads. If you look very carefully, there's a road straight down from where we are. So let's move the cat there. And then we could choose to use the move steps command or the glide. I think for today we're going to use mostly the glide command. And not to a random position, to about a specific location. And so we'll put that right there. No, I don't think I want it to move that fast. Let's add a looks command. Say hello for 2 seconds. Then we can start moving. And how about I'm going to school for 2 seconds. So when I click the green flag, it starts at the top, says I'm going to school, and then glides down to Evergreen Avenue. The next leg of the journey would be to go to 3900 South. And so I move the cat where I want it to be. I glide. Notice those locations are very different. And I check it again. I'm going to school. It goes down. It very quickly makes it down Evergreen. Maybe that glide was too fast. Let's make that 2 seconds. And this one seemed a little long. Let's make that a half a second. Let's try again. I'm going to school. It moves down. That's about the same speed. At this point, we could keep adding glide commands until we're at our destination, but I'd like to show you a different way using the move command. In your project, I would recommend using one or the other, but not necessarily both of these methods. Each have their advantages. So the other way to use the move command, if you remember from the worksheet, move cares what direction we're pointed. So we're going to need a point in direction command and a move command, and we're going to need a loop. So let's get a repeat loop. The structure will be something like this for each of the next segments. So at this point, let's look where I am. The cat is sitting at x equals 82, y equals 115. I want to move down to, we'll say, to the intersection at 39th South. The x shouldn't have changed, but the y does, to minus 60. That means I have to move from 115, we'll call it 120, to minus 60. That's 180 steps. That would be repeating 17 or 18 times. Move 10 steps. The product of these two, 17 times 10, will be how many steps in that direction we move. But we don't want to move to the right, we want to move down. So let's put that at the bottom of our commands and see what happens. We move down to evergreen, we move over, and boy, that was fast. Let's slow it down. The way to slow it down would be to move fewer steps. Let's say 5 steps at a time, but repeat more times. So there's 34. That's the same product. Does take a little bit of math to do it this way, or just a lot of trial and error. So we go down, we go over, and then off we go. That looks about right. Something I do notice is that during the first part we're pointed down. That's okay, but initially we should be pointed up. So I'm going to grab a couple more point in direction commands. So point in direction, let's point in direction 90 for the first segment, or for when we say I'm going to school, but then point in direction 180 when we do our first leg, and then back to point in direction 90 when we're going horizontally. Let's try that again. I'm looking to the right, I'm pointing down, I'm looking to the right, now I'm pointing down. That's still a little fast. Let's try moving 3 steps at a time, and then this number will double to something like 60. That's probably a little too much. We'll take 1 or 2 off if it is. No, just right. Now this would be a time. Let's say we've reached 39th South. I'll bet there's a light, so let's say wait for the light for 2 seconds, and then we can continue to move forward. I will just duplicate. I right-clicked where it said repeat. It's going to copy everything below that. And I will tack it onto the bottom. Wait for the light for 2 seconds, and then we don't want to go another 60. We only need to go, oh, probably 10 more steps. Let's try that. Okay, going across. We go down. That's a good speed. We wait for the light. We go a little bit more, and then we need to point in direction 90 to cross the street. One more time. Motion, point in direction 90, and then we'll just do this one more time. It's getting kind of confusing here. We wait for the light. This one we didn't need. I just slid that up, and the wait for command that the say command that I didn't want went away. So let's back up. I did a lot of stuff there. We wait for the light. We move 10 more times, 30 steps down. Then we point in direction 90 to cross the street crosswalk. We repeat 10 times, move 3 steps. That looks about like the same distance. And then at the very end, we say, I'm here. For 2 seconds. Let's try that one last time. wait for the light, and then I'm here. Maybe we should say I'm here using the say command without the 2 seconds. I'm here, and then that will stay there. That comment will stay there forever until we hit stop and replay. So I'm going to school. We go left, right, we go down, we wait for the light, we go through the intersection, and then say I'm here. Let's see how we did as far as the rubric goes. Jump back to the program, scroll down to the rubric to Canvas. The background is a map. We did that. The sprite starts at the first destination when the green flag is clicked. We did that. It moves along the streets. The sprite points in the correct direction depending on which way it is moving. That's why we need all those point and direction commands. The sprite indicates when it has arrived at its destination. It does that. We haven't done the enhancement. Add a feature of your own choosing that involves movement or animation. I've seen students do additional sprites which move along the streets, but maybe have other destinations. Sprites switch costumes while it's moving to simulate walking, or the sprite goes to multiple destinations announcing each one as it arrives. I'll let you decide which of those to choose and how to implement them. If you have any questions in doing that, please send your specific questions to me. The easiest way would be to submit the assignment for grading, but then include in a comment as to what questions you have regarding it. I answer the questions, and then you can resubmit after you have completed it. Look forward to seeing what you come up with, and we will see you next time. Thanks.